Hi, my name is Oktay. Welcome to today's video about the chemical element antimony. This is a nice picture of antimony, which is a silvery and brittle semi-metal. The discoverer is unknown. Antimony has the atomic number 51. Its name comes from the Greek language. Antimonium means a metal not found alone. And the symbol Sb comes from the Latin language, means stibium. That's stibnite, which is antimony sulfide. And there are two stable isotopes, the 121 and 123. So this again the rule, isotopes with the even number of neutrons are the stable ones. However, this rule has a exception, and that's beryllium. This metallic antimony is the most stable of four allotropes. Allotropes are different forms of the same chemical element, and the melting point of antimony is 631 degrees Celsius. This is a picture of the nucleosynthesis of the origin of the chemical elements. You can see antimony is here in the nitrogen group under arsenic. And these colors show that antimony is a product of dying low mass stars and merging neutron stars. Antimony is toxic, and the tolerable concentration in water is 20 micrograms per liter according to the World Health Organization. This is a picture of the abundance of the chemical elements in Earth's crust. Antimony is here. Almost the same level as iodine, much less than, for example, arsenic. The concentration in Earth's crust is just 0.2 parts per million. However, there are over 260 known antimony minerals. These are three examples of antimony in nature. At the left, that's native antimony from the Limpopo province in South Africa. In the middle, that's stibnite, which is antimony sulfide from Baiut in Romania. And at the right, that's aurostibite, which is a gold antimonide from Krasna Hora nad Vltavou in the Czech Republic. This is how you can make antimony. There are two ways. First is a reduction with scrap iron. Antimony sulfide plus scrap iron, you get antimony element plus iron sulfide. The second way is roasting of sulfides of antimony, and then a carbothermic reduction of the oxide with carbon, and you get 4 antimony and 3 CO2 molecules. And both these processes are energy intensive. It's the same problem as like, for example, aluminium or the rare earth metals. That's how you can make antimony. This is the global production of antimony in 2022. Was 110,000 metric tons. Number one producer is China with 55% of the production. Number two, Russia. Number three, Tajikistan. And you can see in the recently there was a decline, and this is because of stricter regulations, environmental regulations in China. This is one use of antimony compounds as a flame retardant. At the top you can see polyurethane foam burning. At the bottom, that's polyurethane foam, which is treated with antimony compounds, and in this case, the fire stops. There's another use of antimony is in lead acid batteries, adding it as an alloy to lead, and this gives better strength and better charging properties to the lead acid battery. This is a solder joint in a circuit board. Solder is an alloy of tin, and in this alloy antimony can replace lead. However, this makes the alloy a bit less stress resistant. That's why there are exceptions for the where lead use is allowed, for example in the aerospace industry or in the military. This important compound, antimony trioxide, Sb2O3, It can be made by roasting of stibnite, which is antimony sulfide, or oxidation of antimony metal. It is used as a flame retardant for rubber production, for glass, and in the ceramics industry. And it is its effect on the human health is not clear, not well understood. This is one use of antimony oxide for the production of PET, polyethylene terephthalate. The world production 2021 was 21 million tons. This is a $37 billion market. PET is one variant is polyester. This is a fiber for textiles. And at the left you can see a PET bottle, and to the right that's preform. And PET is also used for cables. Antimony trioxide is a catalyst for the production of PET. That's why PET contains small traces of antimony trioxide, which can leach over time. This antimony trisulfide, Sb2S3, is known in nature as the mineral stibnite. It has semiconductor properties, and it is used for safety matches. In 1817, John Mercer discovered antimony orange that can be used for cotton dyeing, which is a mixture of antimony trisulfide and antimony trioxide. This is a nice picture of a fresco at the tomb of Nebamun. Grinded stibnite was used as coal. Coal is an ancient eye cosmetic and medicine for eye infections. And this picture is from 1400 before Christ. And coal was known and used since 3100 before Christ. This is the Marsh test. Last week I made a video about arsenic. That's one way to test for arsenic, but also for antimony. You add zinc and sulfuric acid to your sample. Make these hydrogen compounds. In the case of arsenic, it's arsine, AsH3, and antimony you make stibine, SbH3. Both compounds are very toxic. Then you make this. Then you burn these compounds to make these mirrors. And the point is, the arsenic mirror is soluble in a solution of ammonia and hydrogen peroxide, but the antimony mirror is not. There's another simple way to test for antimony. That's the iron nail test. In this case, you add water to your sample, mix it, and put a nail into this mixture. And if the sample contains antimony, then the antimony ions will be reduced by iron, which will give the iron nail a black surface from the antimony atoms. That's how you test. This indium antimonide, this is a semiconductor with the highest electron mobility. It can be used for transistors and infrared detectors. This is the Space Telescope Spitzer. Artist concept. It has an infrared camera with indium antimonide detectors. The Spitzer Space Telescope had a big part in the discovery of the TRAPPIST-1 planetary system, which is in a distance of 41 light years. It's a very interesting candidate for future missions like James Webb Space Telescope, because it contains 7 Earth-sized planets, and in the best case, several of these planets could be not only Earth-sized but a bit Earth-like. This is stibnite, antimony sulfide crystal from Japan at the University Tübingen in Germany. This is antimony trioxide, which is also called valentinite, antimony Sb2O3, a mineral from Jebel Nador in Algeria. And this is pecunite, antimony arsenic sulfide from Dafeng in the Nanning prefecture in China. And these are stibnite crystals, Sb2S3, at the Carnegie Museum of Natural History in Pittsburgh, USA. That was today's video about the chemical element antimony. Thank you for watching. Have a nice day. Bye bye.